Let's do a problem from your lab assignment, section 11.9. This is number 1. Find a power series representation for the function, and then after that determine the interval of convergence. And we're centering around 0. Our function is 1 divided by 6 plus x. Well, this looks a lot like our geometric series where we have 1 over 1 minus r, and that is the result of an infinite series where we just add the r being raised to power, so that's essentially r to the n. So we can say that this is what we have, r to the nth power, as n goes from 1 or 0, n goes from 0 to infinity. Now, what we want to do is we want to make our function look like 1 divided by 1 minus r. Now, there's a 6 here that we probably would need to factor out. And so we can factor out a 6 from the denominator. That leaves us with a 1/6. The numerator stays the same. Now, we took out a 6, so this 6 becomes a 1. And then now we have an x. We take a 6 out of that. Well, there's no 6 to be taken out, so we're going to have to force a division, x divided by 6. And what you can do is you can distribute the 6 to the 1 and x over 6 to see that you're going to get 6 plus x. Oops. It looks like there's a plus here and there's a minus here, so let's throw a negative sign in there because our series has a negative sign here as well. Okay. Now that we have that, we can identify our r value as negative x over 6. So the r value is negative x over 6. And so we can put that into our expression. So our r value is negative x divided by 6. And our series is r raised to the nth power, so that's r raised to the nth power. So now that we have that, we can separate the negative sign and have that as an alternating series, and then we just have an x over 6. And then now we can rewrite our series as 1 over 6 times x over 6 to the nth power. And so the numerator will just be x to the n, and I have 6 here, and I have a 6 to the nth power. So this would be 6 raised to the n power times 6. So that's essentially just adding the powers. Therefore, this thing is equal to get this 1/6 into there, it's going to be equal to this whole thing. So we have an alternating series. That's a minus 1 raised to the nth power. And then we have a series after that, x to the n. Oops, let's take this from the numerator and put it in regular. X to the n. And then, oops, x to the n. And then let's divide by 6 to the n plus 1. So there's a lot of ways of writing this. They wrote it where the 6 is also in a numerator, and they just put negatives in front of the power, and so it's the same expression. So we know that this thing, so this is a series, by the way. So now that we have the series, we know that this thing has an interval of convergence from -1 to +1, which means the series is going to converge for absolute value of r less than 1. So we just essentially take the absolute value of r, this is our r, to be less than 1, and then we find a series, the interval of convergence. So if we do this, the negative signs would go away, and then we would have a plus or -1 less than x over 6 less than 1. And then when you finally multiply by 6 on both sides, you'll get -6 on the left side and then +6 on the right side. Now it's going to converge at the endpoints, and so we're going to have open parentheses here. All right, hope that helps.